Hey, thanks for joining me at this year's OpenNebulaCon 2022. My name is Andrew Gracie, and I am the product manager for Cloud Native Edge at SUSE in Rancher. I want to give a shout out to the OpenNebula team for inviting me to do this session. And yeah, I wanted to quickly talk about what is K3s and how to use it at the edge specifically. So I'm going to kind of go through a couple different pieces. First, I'm going to talk about what is K3s. I'll kind of do a quick deep dive into what's actually in the box, what do you get by default, a little bit about how to install and use it. And then lastly, I'll kind of talk through some of the edge considerations when you are deploying K3s in a distributed manner. So what is K3s? K3s is a lightweight CNCF conformance Kubernetes distribution produced by Rancher Labs. Um, it is roughly a 50 megabyte binary that you can download and run. It consumes roughly 500 megabytes of RAM at rest, and obviously, depending on your CPU, very little, right? And it's also supported for x86 64, ARch64, ARM7, and S390X. So we've got a very wide range of CPU architectures that we can support. Um, yeah, so because of this size, it really makes it very attractive to install in smaller footprint devices. Think like Intel NUC, Raspberry Pi, something along those lines. Where imagine like if you're a company and you're buying 20,000 nodes to deploy across all of, say, your retail stores. You don't want to spend a lot on hardware because obviously those costs add up quite a bit. So you really want something. The hardware that you're going to be buying is going to be consumer grade and relatively, or at least comparative to data centers, relatively cheap. So with that, we also need the control plane that actually does the scheduling and running of the work. We need this to be as cheap or as computationally cheap as possible so that you can take the fullest advantage of the hardware that you have at the edge. Yeah, so what's in the box, right? So Kubernetes is at some level a spec of how to orchestrate and run workloads. So you get basically to be CNCF conformant, you have to have certain guarantees, you have to have certain components in there, but within those components, you get to kind of pick and choose what exact component you want. Yeah, so for the Cube API data store, which is typically etcd, we actually, for K3s, we use a component called Kine. Kine literally means Kine is not etcd. This gives us a kind of a shim layer for the data plane so that you don't have to use etcd. This is super useful for a one or two node configuration. For one node configuration, we actually default to using a SQLite data store. But you can also use etcd, an embedded etcd specifically, or you can actually back it by Postgres or MySQL. So there's a lot of flexibility that we offer by using this kind shim layer. For the container runtime, the actual piece that runs the containers itself, we use containerd and then containerd uses runc. For the default CNI, the container networking interface, we have picked Flannel. This gives you a very simple overlay network that basically allows us to give that simplicity there. You can disable Flannel and use something else if you wanted to, but by default we use Flannel. For the kubedns piece, we have chosen core DNS. For the ingress controller, which would be like your HTTP load balancer, and if you're new to the Kubernetes world, there's kind of two different layers of load balancing. You actually have your network load balancing, and then your ingress controller, which allows you to do things like host and path-based routing from the network load balancer to the workloads themselves. And so for the ingress controller layer, we have chosen Trafic. Um, Again, just like with most of the other components, you can disable Trafic and instead use Nginx or Ambassador or whatever ingress you would prefer to use. But Trafic does come supported out of the box. For the load balancer, we use a component called Clipper. Clipper is kind of it's not quite a load balancer in your traditional sense, but it does give you a good place to start when you're dealing with smaller clusters. What it does is it allows you to assign services to be load balanced, and then across each of the nodes in that cluster, say you've got 3 nodes set up. The load balancer would expose that service on its specific port across all of those nodes, which is different from like a node port service, which would expose it on just the node where it is, where the service is running. So this gives you a really nice way to kind of get up and going. But as soon as you start needing like multiple workloads running on port 80 or 443, you might want to drop this and replace it with, say, like Metal Cubed or KubeVip, I believe is the other good option for bare metal. And then lastly, we've got a local path provisioner that gives you a way to handle persistent volume mounts in a way that basically gives you the that is CSI compliant, which is a container storage interface. Because it is on the CSI, you could definitely drop local path provisioner and use the CSI of choice. Being that I work at SUSE and Rancher, I'm obviously going to be biased towards Longhorn, but you could replace it with whatever CSI you want, or you could use them in parallel depending on what the workload actually needs. So I stole a couple of the architecture slides directly from K3s.io, but I figured I could talk through them briefly. So for a single node control plane, this is vaguely what an architecture looks like. We have a K3s server or control plane with an embedded SQLite or SQLite database on your server node, and then either that can be just a single node also running your workloads, or you can start adding additional agent nodes, or also called worker nodes, to that if you need to scale out a bit as far as compute power goes. Then, yeah, basically that would split your control plane from your agents and give you that scaling. But you won't be HA for your control plane. This is super useful for smaller deployments and especially in development labs. We also support an HA control plane, or sorry, highly available control plane, that you can actually use multiple control plane nodes or server nodes in this example, where you have the option of either having an embedded etcd as part of that, or you can actually tie out to an external database, again, etcd or Postgres or MySQL at the moment through that kind interface. Again, those server nodes can host the workload, or you can have additional agent nodes and set up. I'm not going to come up with a word. I apologize. But you can basically say the server nodes can't run additional workloads, and everything needs to be run on the agents. Again, with this, you would have potentially an external load load balancer dealing with that traffic. Here is kind of a more in-depth version of what this kind of looks like. For the sake of time, I probably won't go into any detail about this, but this is how it looks. There's a little bit more detail on the website about this piece. Yeah. So how do you actually get K3s, right? There's a lot of ways to get K3s. The top line is the command that you would run. This is again directly from K3s's website, but you can run this curl command and then sh it. Now, granted, I would probably not run this command in production. I would probably curl and then make sure that you've got the right thing and then run that command, run the command that you just downloaded. For the sake of security, but this will get you up and running really quickly. The next is we have a project called Rancher Desktop that installs K3s as onto your desktop environment. This is a really nice way to get up and running. It has a couple of really nice features around, like you can choose what version you want in a UI or even in a CLI. You can really quickly reset your Kubernetes environment to kind of quote unquote factory default, which is super nice when, especially if you're doing active development and you screw something up and you just want to kind of reset. There is K3s up, or I think he typically pronounces it ketchup, by Alex Ellis, which is a fantastic tool that allows you from one computer to install K3s and other components onto a variety of machines with SSH. It's a super clever implementation and very user friendly. Highly recommended. And lastly, there is K3d, which is a way that you can run multiple K3s clusters on top of Docker. So if you're running Docker or the open source version Moby, you can then use K3d to spin up multiple clusters quickly. Next, we've got kind of advanced usage, a couple different options that I wanted to call out. You can set up an external data store for if you want to scale differently than the standard implementation. Almost everything is configurable, so you can turn off all of the individual components. This is well documented on the website. And lastly, you can actually add additional manifests during your installation. So you can actually set up like, hey, here is my Metal 3, or sorry, you can tell I'm working at the edge, my Metal LB and Nginx or whatever else you want to override. You can set up that YAML in a specific folder, and K3s will just will go ahead and run that when it installs and comes up. So there's a lot of different configuration options that we have. And then lastly, I kind of wanted to go through, and I'm running out of time a little bit, I want to go through some of the considerations that you might need to think about, and at least how we are solving this at the edge. Naturally, we are the vendor who builds this, so I'm going to be biased towards our solutions. Naturally, there are a lot of different solutions, and the ecosystem is relatively healthy here. But when we're talking about the edge, we are typically talking about a lot of small clusters. So it might be that you have 20,000 clusters spread around the world, right? So that makes it really hard to actually manage 20,000 clusters, right? So we have a component called Fleet that allows you to do GitOps at all of those clusters. And so you can kind of set up some central configuration that everything kind of responds to in a pull-based way, so you can manage intermittent networks. Also at the edge, you typically have, you probably don't have too much compute, and you're probably limited on your network throughput and your network stability. One of the components that you might want to think about when you're dealing with this is setting up a pass-through OCI cache, so that all of your images actually come through, say, Docker's distribution, for example, and then go out to all of your nodes. This allows you to have more stability when we're actually talking about what's getting pulled through, and also you're going to decrease your network traffic as well. For remote management, again, you're not going to manage each cluster individually. So a tool such as like Rancher that can do all of the upgrades of K3s, your OS, the workload, right? All of that can be managed through a tool such as Rancher, or pick your higher order management of choice. And then lastly, the one that is a little bit uh, new to us is storing and forwarding of metrics and logging. So metrics and logging can take up a lot of your network bandwidth. So you want to figure out a way that you can kind of cache it locally until it's actually needed farther upstream. Prometheus does this or can do this naturally just due to how it's architected. Logging is a little bit of a to be defined area. I believe OpenTelemetry has some specs out there around how they're going to manage this, and we will follow suit or even help as we can. So yeah, hopefully that was a useful introduction to kind of what K3s is and kind of the considerations that you need to think about at the edge. Thank you for watching.